Okay, we're looking at exercise 11C from the first year mechanics textbook. So we're looking at maximum and minimum problems involving variable acceleration. So we've got an expression for displacement in terms of time, and then we've got a graph of that, and we can see it's a cubic function. And we want the time at which p is moving with minimum velocity. So we've got the displacement is 0.4 t cubed minus 0.3 t squared minus 1.8 t plus 5. Okay, so I can get its velocity by differentiating displacement. So that's going to be 1.2 t squared minus 0.6 t minus 1.8. And I want to know when the velocity is a minimum. So that's going to be where velocity has a stationary point. So I'm going to differentiate velocity. So that's going to be 2.4 t minus 0.6. So when is that a stationary point? Okay, so that's going to be a quarter. Okay, so I haven't actually clarified that's a minimum. So let's go back to the question. So determine the time at which p is moving with a minimum velocity. So I know that that is going to be a stationary point for velocity. So I know it's either a minimum or a maximum. As it's the only answer, I don't think I need to bother finding the second differential and showing that it's that would give me a minimum value for velocity, because it's not going to be a trick question. So if there is only one stationary point, I'm going to assume that that's a minimum stationary point. Okay, so find the displacement of p from O at this time. So that's actually a little bit easier. So assuming our answer to A is correct, I'm just going to substitute back into that. So, okay, so I'm using this expression here. So S is going to be 0.4 times 0.25 cubed minus 0.3 times 0.25. Start a bit lower, 0.25 squared minus 1.8 times 0.25 plus 5. Okay, so bear with me, I'll just try and quickly type that in. So 0.4 times 0.25 cubed minus 0.3 times 0.25 squared minus 1.8 times, nope, there's something funny there. Sorry, okay, so minus 1.8 times 0.25 plus 5. Right, assuming I entered that incorrectly, which I'm not totally sure I did. I'm getting 4.5375. I'm just going to check that's the right answer, because I might have entered that correct. No, that's fine. Okay. Okay, so I'm around that to 3 significant figures, and that is the displacement, so that's going to be in meters. Okay, and then it wants the velocity of p at this time. So I've got the velocity up here. So let's just copy that out again. So velocity is 1.2. Well, let's copy it out and sub in the 0.25. So I'm looking here. So it's 1.2 times t squared minus 0.6 times t minus 1.8. Right, I'll type that one in a little bit quicker. So 1.2 times 0.25 squared minus 0.6 times 0.25 minus 1.8. Okay, so that's giving me minus 1.875. So I'm going to round that to 3 significant figures. And that's velocity, so it's going to be meters per second, and I think that was the right answer. Yeah.